Kia ora, I'm Andrew. This is the calorimetry lab. This lab will be using solutions of ammonia and hydrochloric acid, which are corrosive. If you get any on your skin, wash it off immediately and then notify a demonstrator. The aim of this experiment is to determine the standard enthalpy of formation of solid ammonium chloride. The molar enthalpy of formation of a substance is the enthalpy of reaction when 1 mole of a substance is formed from its elements in their elemental forms. For solid ammonium chloride, this reaction is difficult to carry out directly due to 3 gaseous reactants, so we will use Hess's law to determine the enthalpy of this reaction indirectly. In this experiment, you will measure the enthalpy of either the reaction of aqueous ammonia with hydrochloric acid to produce aqueous ammonium chloride, or dissolving solid ammonium chloride in water to give aqueous ammonium chloride. We will combine these enthalpy values with other literature data to determine the enthalpy of formation of solid ammonium chloride. Before you get started on your experimental work, prepare your graphs as shown in your lab manual. It's really important that you do this before the experimental work because you need to plot as you go. A complete graph has a descriptive title, axes with appropriate ranges and constant scale, axis labels with units if necessary, clear data points marked with crosses, and lines of best fit through linear data only. We will be using 2 thermometers, an electronic thermometer, a thermistor, and a manual thermometer. Use both to measure the temperature of a beaker of water, allowing a few moments for the reading to stabilize. If there is a difference in the temperatures, take the thermistor as correct. Note on your report sheet the difference in temperatures between the 2 thermometers, whether that's positive or negative. Next, assemble the calorimeter. This comprises the styrofoam container with the beaker, the stirring rod, and the thermistor. All 4 components must be present for the calorimeter to be complete. Take the required amount of cold water measured using a measuring cylinder and pour it into the calorimeter. Next, take the other beaker and place it on the Pynex block. Take the other stirrer and place it inside the beaker. Take the thermometer and place that inside the beaker too. Next, using a measuring cylinder, go to the hot water tap and measure out hot water from the tap. Make sure it is actually hot. You'll be working in pairs, so one of you will work with each solution. Gently lift and lower the stirring rod to stir the solutions. There should be little to no noise. Take the temperature of each solution every minute for 5 minutes. It's very important that you plot them on your graph as you go. After 5 minutes, pour the hot water into the calorimeter quickly and then measure the temperature using the thermistor. Record the temperature at the time of mixing as quickly as possible. Record the temperature of the solution every minute for 10 minutes, stirring gently throughout. Fit straight lines to the changing temperatures of the cold water, hot water, and mixed solution. Extrapolate these straight lines to the time of mixing. You'll see an example of this in your lab manual. Using the temperature differences you have determined, calculate the calorimeter constant, following the procedure in your lab manual. Be very careful to use the appropriate units throughout. Now that you have calculated the calorimeter constant, you will be assigned to one of 2 groups. If you have been assigned to part 1, the enthalpy of neutralization, you will find the procedure is quite similar to that of the calibration. Making sure your beakers are clean and dry, assemble the calorimeter once again and the stirring rod and thermometer in the other beaker. Measure out the required amount of hydrochloric acid solution and pour it into the calorimeter. Measure out the ammonia solution and pour that into the other beaker. Again, stir your solutions and take the temperature reading every minute for 5 minutes. After 5 minutes, pour the ammonia solution into the calorimeter and quickly take the temperature reading. Take the temperature reading every minute for 10 minutes as before, stirring gently the entire time. Remember to prepare your graph beforehand so you can plot as you go. Use the change in temperatures to determine the change in enthalpy. Use this enthalpy value to write on the whiteboard and share with the class. The average of all the class values is what you will use for your final calculations. If you have been assigned to part 2, the enthalpy of solution, again make sure you have assembled your dry calorimeter. Pour the required amount of water into the calorimeter and take the temperature readings every minute for 5 minutes, stirring gently the entire time. While one of you is stirring, the other one will add the ammonium chloride powder to the calorimeter. Take the temperature as soon as possible. Again, stir the solution gently and take the temperature readings every minute for 10 minutes. Again, use your change in temperatures to determine the change in enthalpy for this experiment. Take your calculated enthalpy value and write it on the whiteboard to share it with the class. We will again use the class average to do our final calculation of the standard enthalpy. Now, clean up your bench and leave everything as you found it. Use the Hess's law equation in your report sheet. Plug in the values provided in your lab manual and the averages of the class data. This will give us the standard enthalpy of formation of solid ammonium chloride, which we could not have directly measured. Good luck and enjoy the lab.